you to graphing points, scatter plotting them, finding the strength of the correlation. Now what we're going to do is we're going to try to introduce you to finding the line of best fit by hand and what is an interpolation and extrapolation. So first we have definitions. I do want you to write down this set of definitions. So go ahead and pause. So the first one is a line of best fit. So we go out and graph these points on and get our scatter plot, and we want to make an equation, a line that is the smallest amount of errors between those points. So today we're just doing a judgment of where that line might be. As we move through the class, we're going to do some things called linear regression, which we'll be able to calculate it a little bit more exact. Then we have two more definitions, interpolation and extrapolation. Interpolation, let's say we give you a set of data points. All the points that are in between the given values is called your interpolation. Anything outside of those given values is called an extrapolation. So I will show you in an example in just a little bit. All right. So if you want to pause and read about the line of best fit, the only thing I would say you need to write down on this is it's going to be in slope-intercept form. You probably remember slope-intercept form. M is your slope, B is your y-intercept. Y-intercept. So that's your line of best fit equation. All right. So here's that example that I was talking about I wanted to get to. There's more information here than you probably need, but I like this picture. So let's pretend we give you some data points. Here are all the given data points. We've got out and graphed them. Everything within those data points are interpolation, okay? Now, if we want to make judgment calls later, like estimating, anything outside, so anything above here or below here, are called extrapolation. Things that are not inside that data set. So let's do a quick example here. So there's a problem where you have age is your x-axis, and distance a discus throws is your y-axis, and it's in meters. So we go out and graph these data points. You'll see them all in the black here, okay? So these are all your data points. So everything in here is your interpolation. Now, two questions. Number one, we want to make a prediction. So we made our line of best fit here in the green. So we kind of went through and just did an approximation. And we want to then make a prediction of what might happen. So let's pretend we have a 14-year-old. So we go down here, here's your 14-year-old, and we want to figure out what prediction we think that 14-year-old will be able to throw a discus. And you're going to see this number 26. So how we get this is we go to 14, we go up to that line of best fit, the green line, and then we go across, and we read that number on the y-axis. It's about 26. So we're making a prediction that this 14-year-old will be able to throw a discus 26 meters. All right, and we can make that prediction because it's inside the data points, interpolation. All right, now let's go to the second question. We now have a 30-year-old. This 30-year-old, we want to make the prediction, and we go across, and it's about 78. Notice that this green line is outside our data points. This is an extrapolation question. The problem is it's outside, so we really can't make a judgment call. We can't really predict that it's 78. It's unreasonable because it is outside the data point. It's not an interpolation, it's an extrapolation. So we can't make a judgment call. So you can't predict outside the data points.